Hi there, Wildcats. Welcome to your geometry class. In this video, you will be learning about different properties of special parallelograms. And our objective is we're going to use these properties of these special parallelograms to solve a given problem. But what are these special parallelograms? One is your rhombus. Second is we have your rectangle, and we also have your square. Essential question in this matter is what properties of these special parallelograms differentiate them from other parallelograms? Okay, so study tip. Okay, so remember, or you have to recall that a rhombus is a parallelogram, so it has all the properties of parallelogram. Same with rectangle and same with square. Okay, let's jump into our first, which is we'll cover about rhombuses. Okay, so we have example A and example B. All right, example A here is parallelogram ABCD is a rhombus. What are the measures of angle 1, angle 2, angle 3, and angle 4? All right, so take note of this. All four sides of a rhombus are congruent. So I want to write that here. So all four sides, all four, sorry about that. All four sides of a rhombus are congruent, are congruent. Okay, by the converse of the perpendicular bisector theorem, your B and D are on a perpendicular bisector, your B and D are on the perpendicular bisector of AC, so from A to C. So we can tell that your AC, okay, is perpendicular to BD, okay? So AC is perpendicular to BD. Therefore, they form a 90-degree angle, or when we say 90-degree, this is a right angle here. So they form a 90-degree angle, which is a right angle. Therefore, okay, so you are looking at angle 1, angle 2, angle 4, and angle 3. So all four angles form by the intersection of the diagonals. Okay, I'll repeat that. All four angles, angle 1, angle 2, angle 3, and angle 4, form by the intersection of the two diagonals, which is a 90-degree in measure, which is a right angle. Therefore, the measurement of angle 1, the measurement of angle 2, the measurement of angle 3, the measurement of angle 4 are all congruent, which is 90 degrees. Okay, next one, letter B. So the parallelogram JKLM is a rhombus. Okay, how are angle 1, 2, 3, and 4 related? This is because the given parallelogram already stated there that it's a rhombus. Okay, it's a rhombus, and all of the sides are congruent. Okay, and there is a diagonal here. So you see this one, JL. JL is congruent to JL, of course, by reflexive property. JL is congruent to JL. If this is congruent, this side is congruent, and all of those sides are congruent, therefore by SSS, side, 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 all of the sides that are in there, to prove that the two triangles that is involved in your rhombus are congruent, by SSS, triangle, this one, JKL, triangle JKL is congruent to triangle JML by SSS. Okay, so I'll just write there. So angle 1 is congruent to angle 2.
Plus One is a 2013 movie directed by Dennis Iliadis,
Angle
starring
3
Reese Wakefield,
is
Natalie
equal
Hall, and
to
Ashley
angle
Hinshaw.
4. Okay, I'm sorry about that. The diagonals of a rhombus bisect the angle of each vertex, right? I'll repeat that. The diagonals of the rhombus bisect the angle of each vertex. Okay, next one. So those are the two examples that we have for rhombus. So as we can see here on the next slide, you will have the theorems about rhombus. Theorem 6-16, if a parallelogram is a rhombus, then its diagonals are perpendicular bisector of each other. So the two diagonals, if they are rhombus, the two diagonal bisect each other, and it's a perpendicular. Okay, meaning they form a 90-degree angle in their intersection. And theorem 6-17, if the parallelogram is a rhombus, then each diagonal bisect a pair of opposite angles. Therefore, if you are looking at the measurement, I'll just move this one here. If you will see that the measurement of the rhombus here, as you can see here, if this is 63 degrees, then this is also 60 degrees. So the diagonal bisect the angle, which the vertex. Okay. So you see that if every time I move my mouse there, it always be the same, because every time you draw your bisector, okay, it bisect your angle also. It will change, and definitely it will be the same, and they are congruent. All right, so let's do another one here. Your remember these two theorems, guys. If you can pause this video so you can take this down for future references. Now we are going to apply those theorems that we have. So we're going to find the length and angle measure of a rhombus. So a quadrilateral ABCD is a rhombus. What is the measurement of ADE? So we are looking at the measurement of ADE, this one. So we are looking at this angle here, ADE, so this measurement here. Okay, so AC, your AC bisect BD, or AC bisect your angle BAD. Okay, therefore this one is also 53 because of angle bisector. So we have we have AC is perpendicular to BD. So AED, this one, is a 90-degree angle. Okay, because they bisect, so they form a 90-degree angle. So if this is 53 and this is 90, so if I'm going to add all of this, including your angle measure here, then it will give me 180 degrees. So the measurement of angle DAE plus the measurement of angle AED plus the measurement of angle ADE is equal to 180 degrees. Okay, DAE is 50 degrees. Okay, plus AED is 90 degrees. And of course, the measurement that we are looking at, the angle ADE, is equal to 180 degrees. Okay, therefore, if you're going to transpose this one, it will give us the measurement of ADE is equal now to 37 degrees. So that if you will add 53 plus 90 plus 37, it will give you 180 degrees. Remember, there are some common errors here on this example. You may incorrectly state that the measurement of ADE and the measurement of DAE, that they are the same. Remember, always remember the middle letter is the vertex of the triangle. Okay, so you are measuring that vertex of that triangle. It's the middle letter. So ADE, so the common error here is that ADE is different from DAE. So ADE, it's this angle here. DAE, it's the 53 degrees. Okay, remember that consecutive angles are not necessarily congruent. All right, let's proceed to letter B example. So letter B would give us quadrilateral GHJK is a rhombus. What is the measurement of GH? So we are looking at this measurement here. If all of these are congruent. So step one, we have to find the values of x. Okay, I'll put there. Step one, find the value of x. So you have to find the value of x. We have to use your 2x plus 3 is equal to 4x minus 7. Mr. Why did you set up as an equal? It is because GJ is a diagonal of the rhombus. And it says there that your GJ and HK are perpendicular bisector to each other. So your GJ was bisected by HK. So this G until here will be congruent to J until the middle also. All right. So they are congruent. So we can have 2x is equal to 10. So divide that by 2, x is equal to 5. So we already have the value of x. Then step 2, your step 2 is hj is equal to 3 times 5 plus 1 is equal to, I'll repeat that. So hj is equal to 16, right? So we have our hj here, which is equal to 16. Thus, all of the sides of a rhombus, based on the definition of a rhombus, they are all congruent. And also, you can see this little symbol here. That's the symbol of congruency, that they are congruent, that they have the same measure. Therefore, GH is also 16. Okay, to answer that question. All right, next example that we have here, we have the theorem for rectangle. Your theorem for that rectangle there is we have 6-18. If a parallelogram is a rectangle, then its diagonals are congruent. Okay, I'll just move this one here. You see this one, it's a rectangle. So every time I move this one, as you can see, your AC and BD those are your diagonals. So every time I move that, it will always be congruent. Remember that the diagonals in your rectangles are congruent. That is a theorem, and it's proven. All right. So let's take a look at this next one here. We have to solve using that theorem that we have there. Let's see. The problem is we have to solve for a word problem, right? So I'm going to read that to you guys.
Paul is training his horse to run the course at a pace of 4 meters per second or faster. Paul rides his horse from D to C to E to B in 1 minute 30 seconds. The figure ABCD is a rectangle. Did he make his goal?
All right, so one of the reasons why I put this one, because I want to integrate your Pythagorean theorem. So in this example, because we know that this is a rectangle here, and your your DB and AE are the diagonals, meaning they are congruent. And what are we going to answer is, did he make his code? And let's see if he did make his code. Remember, you have to use the properties of rectangle to find each segment length and the total distance. Finally, we have to determine his speed. First, we have to compute BD. Where is BD? So we have to compute BD using Pythagorean theorem. So this is a triangle. It's a right triangle. Okay. We already have the measurement of AB. We have the measurement of AD. So we have to look for the hypotenuse, which is your DB or BD. So we have the measurement of BD squared is equal to the measurement of AD squared, which is 80 plus 192 squared. So we have BD squared is equal to 80 squared plus 192 squared. You add them, that will give you 43,264. Okay, and then I'm going to extract the square root of this one. Of course, this will be cancelled. So you have the measurement of BD is now equal to 208 meters. So your BD is 208. So we have to use this property. So this is 208 here, 208 meters. We have to use the properties of rectangle to find the total distance. Okay, we have to find the total distance. So I'm going to erase that. Okay, at least you can visualize the triangle there. So we have CE, okay, CE is equal to EB. Okay, CE is equal to EB is equal to 104. Why is it 104? So 208 divided by 2, that is 104. Okay. Remember that the diagonals are congruent and bisect each other. So whatever you have there around that will give you 104 here. This is 104. This is 104. That is also 104. So you're going to add all of those numbers that we have. Okay. We have your DC plus your CE plus EB, because we are looking at the we're looking at if Paul make his goal, did he achieve his goal? So DC, okay, this measurement here, DC, which is the same as 192, plus your CE, which is 104 plus 104, plus EB, which is also 104. Okay, which is you add them together, it will give you 400. Okay, so we have to determine the pacing now. Okay, we have to determine the pacing. So 400 divided by 90, that will be approximately 4.4. Okay, so Mr. Where did you get that 90 again? The 90, it's from 1 minute 30 seconds, so 90 seconds. So this is 4.4. So if you are going to interpret that, Paul, okay, the interpretation is that your Paul's horse run at a pace of about 4.4. They use meters, so 4.4 meters per second. And yes, okay, he made his goal. He made his goal. There you go, guys. That is one of the example that we have in your rectangle. All right, let's proceed with the last one. How about square? Let's see this example that we have for square there, guys. Figure WXYZ is a square if WY plus XZ is equal to 92. What is the area of WPZ? So it's the shaded region there, right? So maybe we can do this one in 3 steps, right? So step 1, find the length of the diagonals. So we have to find the length of the diagonals. One is find the length of the diagonals. So what we have is W y plus xz is equal to 92. Okay, therefore your wy, which is equal to xz, therefore if they are equal, you divide both sides by 2, then this is 46. So we have 46. So this is this example, your wxyz is a rectangle, so wy is congruent to xz. Yeah, so somewhat like, you know, square is a rectangle and a square is also a rhombus. All right, so whatever properties do rhombus and rectangle have, the same with the square, but the some properties of square, which is all sides are congruent, it's not on not in rectangle. All right, so step 2, because we already know that wz and xz, or wy and xz is 46, they are congruent. So we have now, step 2 is find, or we have to solve for wp and zp. So wp and zp. So we are looking at this too, because we are looking at the area of this one. So wp is equal to 1/2 of wy, which is our wy is 46. So wp is equal to 1/2 of wy, which is 46. Therefore wp is equal to 23. The same with zp. Your zp is equal to the 1/2 of xz. Therefore zp is also equal to 1/2 times 46. So zp is equal to 23. I'll just so we already know that wp is 23, wz is 23. All right, so let's now going to find the area. Step 3. Okay, the area of triangle WPZ. The area of WPZ is equal to the area of the given triangle WPZ is equal to 1/2 the 23, which is the base, 23 times the height, which is also 23. Why? Because this is already 90 degrees, guys. It's already 90 degrees. So the height is 23, then the base also is 23, which is approximately the area of triangle AWPZ is equal to 264.5 square unit. There. So the area is 265 per square unit. There you go, guys, about the properties of special parallelograms. So again, if you have any question, don't hesitate to reach out about this problem, and you can go over and watch over again. So until you understand, and then join us on the live Zoom meeting for question and answer about this topic. Thank you, guys, and we'll see you in the next video. Bye bye, and I hope to see you on our live Zoom meeting. Thank you, guys.